We're going to convert rates and measurements. Yesterday we were finding unit rates. That's a part of what we're going to do today. But we're going to convert those rates into different rates. We're going to use conversion tables. We're going to have a conversion chart. I'm going to show you in a little bit. To change units and rates to different rates and the different units. If you look at this car, this is the fastest land car. It was clocked at 760 miles per hour. That's fast. Okay? But what I want to do is I want to change it to where it makes more sense. 760 miles per hour, that's a large number. That's large enough that you may not understand it. So what we can do is we can change it to something you might understand, such as miles per minute. Most cars going 60 miles an hour go a mile a minute. Let's compare it to this vehicle. So what you do, and this is required, you're required to show your work. The only way you're going to get correct answers today is showing your work. Is taking 760 miles per hour, writing it out. Write out the rate they give you. 760 miles per hour. Then what you're going to do is you're going to times it by a conversion rate. Which means you're going to times by whatever you need to get rid of. I'm going to miles per minute. So I need to get rid of hours. How do I get rid of hours? I do that by timesing by hours with hours on top. Because if they're on opposite sides of the line, they cancel each other out. Now what I do, this is 1 hour. I'm changing it to minutes. I know how many minutes are in an hour. There are 60 minutes in an hour. So that's my conversion rate, is this. 1 hour is 60 minutes. Now what I do is I look to see, can I do my calculations? Before I do calculations, I see if I've got the units I need. Hours cancels with hours. I am left with miles per minute. Is that what I want?
No. Yeah.
Yes, that's what the question asks, right? Miles per minute. That's what I want. So now what I do is I multiply everything on top and write it out. 760 times 1 is 760. I multiply everything on bottom. 1 hour times 60 is 60. So I've got 760 miles and 60 minutes. I divide that. 760 divided by 60, which you are allowed to use a calculator today. 760 divided by 60 comes out to 12.67. You're rounding to the nearest hundredth miles per hour. You're required to show your units.
Not miles per minute.
Oh, that's right. Miles per minute. Sorry. Miles per minute. Okay? Or you could write it like this. 12.67 miles per minute. All right, you need to write down page 276 measurement conversions on your notes. I'm not requiring you to write down this chart, but this chart is on page 276. Anytime you're going from customary to metric or metric to customary, you will use this chart. If you're going customary to customary or metric to metric, you will use the back page of your book that we've used before. But now we're going metric to customary or customary to metric. We're converting measurement systems. So you use this chart. It's on page 276. Write this down. Now we're going to convert units, measurements. Not rates, but just measurements. It's asking me to convert 12 centimeters to inches. And they give me this on page 276. 1 inch is 2.54 centimeters. That is customary to metric. You can use the other one, where it's centimeters to inches. That's fine. It doesn't matter which one you use, but this is the one that I like, I prefer. So write what they give you. They give you 12 centimeters. This is not a rate, so it's not over it's not per anything, so you just write it over 1. It's not by per minute or per hour or anything like that, so you just write it over 1. Then we times by my conversion rate, which I know my conversion rate. It's 1 inch equals 2.54 centimeters. So to get rid of centimeters here, where do I need to put centimeters? On bottom. I know centimeters to inches, so I put inches on top. 1 inch is 2.54 centimeters. Now I cancel what I can. I cancel centimeters out. I'm left with inches. Is that what I want? Yeah. Now you can do all the conversion, which you take 12 times 1 and get 12. 1 times 2.54 and get 2.54. Then you divide. 12 divided by 2.54 is 4.724, which it asks you to round to the nearest hundredth, which is 2 decimal places, which rounds to 4.72 inches. Don't forget your unit. 4 quarts of liters. 1 quart. Okay, this little symbol right here just means it's close to, it's roughly 0.946. It's not exactly because they've rounded, but it's close to. That's what this means. It's just equal to, similar to, okay? So write what they give me. They give me 4 quarts over 1 because it's not a rate. It's just a measurement. So it's over 1. I need to change my quarts to liters. So how do I get rid of quarts? Where would I put quarts? On bottom. If it's on top, I switch it. I put it on bottom. Okay? 1 quart, I found, is equal to 0.946 liters. That's my conversion rate. That's what I found on page 276. I get rid of quarts because quarts cancel out. I'm left with what? Liters. Is that what I'm trying to find? Yeah. Yes. So now I take 4 times 0.946.
3.784.
Which is 3.784. Now it says round the nearest hundredth. So I round. Would I round up or do I keep it where it is? Keep it where it is. Okay. I don't round up with a 4. So 3.78 liters, and that's my answer. It's over 1, so do I need to divide by 1? No. You need to read this and then write down 900 feet per hour and then centimeters per second with a question mark. We're going to change 900 feet per hour into centimeters per second. All right, why we're changing this? We're changing this so we can get a better understanding of the speed of a giant tortoise. 900 feet per hour, okay, that's a long distance. So what we're going to do is we're going to shorten it down to centimeters per second to figure out, is that very fast? Okay, and so we can kind of see on a ruler how far he's going every second, right? So what I do is I write the rate they give me, which is 900 feet per hour. Then I'm going to times it by conversion rate. But the first thing I got to do is decide, what am I getting rid of first? It does not matter which one, but I need to get rid of feet and I need to get rid of hour. I'm changing feet to centimeters. I'm changing hours to seconds. Which one do you guys want to get rid of first? Okay, we get rid of hour? Okay. So if I want to get rid of hour, where would I put it? On top. I'm changing it to seconds, but do I know how many seconds are in an hour?
Yeah.
No. But do you know how many minutes are in an hour?
Yeah.
Yes. There are 60 minutes in an hour. So times by that conversion rate. Is it okay that I go an extra step? Yeah. If I don't know the conversion rate, because I'm at minutes, I need to go to seconds, right? Do I know how many seconds are in a minute?
Yeah.
Yeah. 1 minute is 60 seconds. I cancel out minutes. I'm left with feet per second. Is that what I want?
Yeah.
What's it asking for? Centimeters per second. So I need to get rid of feet and change to centimeters, right? So where would feet need to go? On bottom. It starts out on top, so you get rid of it, I need to put on bottom. If you look on page 276, it does not tell you how many centimeters are in a foot. But do we know how many inches are in a foot?
Yeah.
And do we know how many centimeters are in an inch?
Yeah.
Yes, so we can do that. We can use that conversion rate. There are 12 inches in a foot, and in 1 inch, there are 2.54 centimeters. Now I get rid of all the units I have left. I am left with centimeters per second. Is that what I want?
Yeah.
Yeah. So now I can multiply and divide everything I need to. So I multiply everything on top. 900 times 12 times 2.54. Is 27,432. I put it over the bottom number, which 60 times 60 is 3,600. So I take 27,432 divided by 3,600, and I find that he is traveling 7.62 centimeters every second. Apolo Ohno won a gold medal by skating 12 meters per second. How many miles per hour is this? So what I do is I write what they give me, 12 meters per second. I'm going to change that to miles per hour because I don't understand meters per second. We don't work with meters very often. So what I'm going to do is change it to miles per hour, compare it to a car, and see if that's pretty fast to be skating. So 12 meters per second. Okay, I work through what I need to. It doesn't matter which one you get rid of first, meters or seconds, which one you want to get rid of. Okay, let's go with meters. So meters on the bottom. I need to go to miles. But if you look on page 276, it doesn't tell you how many meters are in a mile. But it does tell you how many feet are in a meter. If you look on page 276, it tells you that 1 foot is 0.305 meters, or 1 meter is 3.279 feet. It doesn't matter which one of those you use, you'll get the same number. One of them you're timesing and one of them you're dividing. I'm going to use the 1 meter is 3.279 feet. Meters would cancel. I'm at feet per second. Is that what I need to go to? No. I'm changing my feet to miles. Do I know how many feet are in a mile? Yes, I do. Look in the back of the book. It tells me that 1 mile is 5,280 feet. So I've got rid of feet. I'm at mile. I'm at miles per second. Is that what I want? No, I need to change it to hours. So I need to get rid of seconds. So if seconds are on bottom, where does seconds need to go? Do I know how many seconds are in an hour?
Yeah, no.
I just told you it's 3,600. But if you don't know, can we go to minutes first and then minutes to hours?
Yeah.
Let's do that. There are 60 seconds in a minute. 1 minute is 60 minutes, in 1 hour. I check my units. I've gotten rid of seconds. I've gotten rid of minutes. I'm at miles per hour. Is that what I need?
Yep.
Yes. Once I've reached that, then I can do the calculations. I take 12 times 3.279 times 60 times 60. I get 141,652.8 over 1 times 5,280 times 1 times 1. So I take the top number divided by the bottom number, and I find out he was going 26.828, which I'm going to round to 26.83 miles per hour. And there's my answer. I'm going to erase all this. You don't have to write any of it down. Okay? But I'm going to show you the other way of doing it. Okay? I have 12 meters per second. I'm getting rid of meters. I'm going to go to feet. Instead of timesing where it was 1 meter is 3.279 feet, I'm going to do 1 foot is 0.305 meters. So instead of timesing by 3.279, I'm going to divide by 0.305. I've gotten rid of meters. I'm at feet. I need to change my feet to a mile. So 5,280. Make sure you're paying attention. Now I need to change my seconds to an hour, which I know 3,600 seconds are in an hour. My seconds cancel out. So I take 12 times 3600, same thing as timesing by 60, and then by 60 again at 43200. On bottom I take 0.305 times 5,280, and I get this, I get 1610.4. I divide those, 43200 divided by 1610.4, and guess what I still get? 26.83 miles per hour. Easy. Okay? So it doesn't matter which conversion rate I used a different one. I went from customary to metric. On the problem before, what you wrote down, I went metric to customary. Okay? Doesn't matter. It changes what numbers are on top and what's on bottom, but you still get the same answer. Okay? As long as you're using the right conversion. Any questions? Here is your homework assignment.